let's see if we can factor the expression 45x squared minus 125. So whenever I see something like this, I have a second degree term here, I have a subtraction sign. My temptation is to look at this as a difference of squares. We've already seen this multiple times. We've already seen that if we have something of the form, a squared minus b squared, that this can be factored as a plus b times a minus b. So let's look over here. Well, over here it's not obvious that this right over here is a perfect square. Neither is it obvious that this right over here is a perfect square. So it's not clear to me that this is a difference of squares. But what is interesting is that both 45 and 125 have some factors in common. And the one that jumps out at me is 5. So let's see if we can factor out a 5. And by doing that, whether we can get something that's a little bit closer to this pattern right over here. So if we factor out a 5, this becomes 5 times, well, 45x squared divided by 5 is going to be 9x squared. And then 125 divided by 5 is 25. Now this is interesting. 9x squared, that's a perfect square. If we call this a squared, then that tells us that a would be equal to 3x. 3x, the whole thing squared, is 9x squared. Similarly, I can never say similarly correctly, 25 is clearly just 5 squared. So in this case, if we're looking at this template, b would be equal to 5. So now this is a difference of squares, and we can factor it completely. So we can't forget our 5 out front that we factored out. So it's going to be 5 times a plus b. So let me write this. So it's going to be 5 times a plus b times 5 times a minus b. So it's 5 times a plus b times a minus b. So let me write the b's down. Plus b and minus b. And we're done. 5 times 3x plus 5 times 3x minus 5 is 45x squared minus 125 factored out.